Welcome back to the AI Research Roundup. I am your host, Alex. Alright, today we're looking at a paper from the Papers with Code trending list, published May 26, 2025, called OpenS2V-Nexus, a detailed benchmark and million-scale dataset for subject-to-video generation. So this paper introduces OpenS2V-Nexus to advance subject-to-video generation, or S2V. Subject-to-video generation is all about creating videos that accurately feature a specific reference subject. This work provides a new benchmark, OpenS2V-Eval, for finally assessing subject consistency, meaning how well the subject's appearance and identity are maintained, new automatic metrics for evaluation, and a huge dataset called OpenS2V-5M. And for those interested in the technical details, the code for this research is available. So if you want to dive deeper into the implementation of OpenS2V-Nexus, you can find the repository on GitHub. It's a great resource for anyone looking to work with their methods or data. Alright, so diving into the benchmark aspect, here compares OpenS2V-Eval with a bunch of existing benchmarks. What we see is that many previous benchmarks were designed for text-to-video tasks, and they often overlook critical details for subject-to-video generation. For instance, they might check for visual quality, or how well the video matches the text, but they often miss out on subject consistency, which is about how well the subject's appearance and identity are maintained throughout the video, and especially subject naturalness. Subject naturalness basically means how realistically the subject appears and behaves, following physical laws and common sense. This new OpenS2V-Eval benchmark is comprehensive, covering all these areas, and notably, it's the only one in this comparison that explicitly evaluates this important aspect of subject naturalness. Okay, and to give you a visual idea of what this OpenS2V-Eval benchmark covers, here shows examples from its 7 main categories. We have things like single face to video, single body to video, and single entity to video, where an entity could be an object like a teddy bear. Then it moves to more complex scenarios like multi-face, multi-body, and multi-entity to video. For instance, generating a video with both a coffee cup and a donut. And finally, there's human entity to video. This range of categories really allows for a thorough evaluation of how well models handle different subject types and numbers. So, complementing this new OpenS2V-Eval benchmark, we have here. This table compares the statistics of the new OpenS2V-5M dataset with other existing video generation datasets. The big takeaway is that while many other large datasets exist, they're primarily for text-to-video generation. OpenS2V-5M, however, is specifically designed for subject-to-video tasks. It provides 5.4 million video clips, all at a 720p resolution, and this amounts to a substantial 10,000 hours of video content. This dedicated focus makes it a really valuable new resource. Alright, so here gives us a look at the pipeline for actually constructing this OpenS2V-Eval benchmark. On the left, under test sample construction, we see that it uses both real images from existing benchmarks like Consus ID and DreamBench, and also synthetic images. These synthetic images are generated from high-quality videos, using tools like GPT-4o for video captioning, and then aggregated into those 7 categories we just saw, like single face or multi-entity. Then, on the right side, under evaluation, it shows the metrics used. We have some familiar ones like visual quality, but also the new ones introduced. Nexus score for subject consistency, natural score for subject naturalness, which uses GPT-4o to check if the subject behaves realistically, and GME score for text relevance. These tailored metrics are key to comprehensively evaluating subject-to-video generation models. Okay, so to give us a bit more insight into the characteristics of this OpenS2V-Eval benchmark, here presents some key statistics. Part A shows the distribution of aesthetic scores for the subject images in the benchmark. We can see that a large majority, well over 70%, score above 5.0, with a good portion even higher. This indicates that the benchmark really uses high-quality visual content for evaluation. Then, Part B looks at the prompt word range. Most prompts seem to fall between 50 and 150 words, which suggests they provide a good level of descriptive detail for the generation tasks. Part C, the prompt word cloud, highlights common terms like man, woman, video, and background, giving us a feel for the typical scenes described. And finally, Part D provides a detailed visual breakdown of the numerous subject categories included, further emphasizing the rich diversity we touched on earlier, covering a wide array of objects, people, and animals. Alright, so we've looked at how the OpenS2V-Eval benchmark is built and its characteristics. Now, here walks us through the construction pipeline for the OpenS2V-5M dataset itself. On the left, we see the overall data pipeline. It starts with creating regular data. This involves data curation, sourcing from the OpenSORA plan, followed by data preprocessing, where they filter for aesthetic quality, motion, and check for watermarks. Then, there's subject-driven annotation. For this, they use tools like Grounding DINO, which is a model that can detect objects and images based on text descriptions, and SAM 2.1, another model that precisely outlines these identified objects by creating masks. Crucially, below that, the pipeline details the creation of Nexus Data. This special dataset component includes cross-frame pairs, which involves linking the same subject across different parts of a long video. It also includes GPT frame pairs, where GPT image 1 is used to synthesize complete multi-view images of subjects from raw frames. The whole point of this Nexus Data is to help models overcome common issues like the copy-paste problem and improve generalization. Okay, so building directly on that idea of regular data versus Nexus Data gives us a really clear visual comparison. On the left, in Part A, we see some example input video frames. Then, Part B shows the output subject images. The top row illustrates regular data. You can see how these extracted subjects, like the dog's head or the person's face, are often incomplete, maybe a bit low resolution, and typically from the same viewpoint as the original frame. In contrast, the bottom row shows Nexus Data. Here the subject images are much more complete, often from novel viewpoints, and visibly higher resolution. This really drives home how Nexus Data aims to provide richer, more varied subject information for training. That visual difference really highlights the power of Nexus Data. Overall, the OpenS2V-Nexus project, with its detailed benchmark and this million-scale dataset, including that crucial Nexus Data, is a big step forward. It's all about helping models generate more consistent and realistic videos centered on specific subjects. This work is vital for advancing controllable video generation. Thanks for tuning into the AI Research Roundup. I'm Alex, and I'll catch you next time.